All right. Hello, everyone. Welcome back to another Python video. Today, we're going to talk about functions, as in making your own functions rather than using built-in functions. Okay. So right now on my VS Code, I have set up the following, just a little simple explanation of how we can create a function, and we'll go in more in depth later on, but we're going to be solving this problem. We're going to determine the number of factors for each number, or let's say for each number, from 1 to n. And we're going to say let n be user input. So if I were to solve a question like this, we've done this before. We would set an upper limit and take an integer input. Then what we would do is set up a for loop starting from 1, but that's where we're going up to, and we're going to include n here. So I'm going to go up to upper limit plus 1. And as this for loop continuously updates num from 1, 2, 3, 4, all the way to num, right? Well, we want to say that we're going to grab a variable and, maybe potentially use a function that calculates the number of factors an input has. So in this case, which is num, right? Rather than writing a very complicated for loop here where you calculate each number's the number of factors it has over and over again inside the for loop, making it very messy, right? What I want to do is make this portion more readable and then just create a function that does and count the number of factors a number has just for a single number. But if I apply that function to all these numbers from 1 to upper limit continuously, then we'll be able to get each answers just like we did prior in a previous solution, okay? So that we can write this output at every for loop. We can say print num has this many factors, okay? So that's our goal. And right now, if I were to run this code, well, let's say we want to analyze all the numbers from 1 to 25. We get an error because factor underscore count is not defined. As in, we haven't defined this factor count function, and it doesn't exist in Python yet. But fear not, we're going to learn how to create a function. To create any function, we have to define them in our program. What I like to do personally is define it before I actually use it in our code. So in your line previous to where you use it, I'm going to create a function called factor count. And then we need to state, well, how many inputs does it have, or how many, what we would like to call arguments. Well, really, we only need a single number because we're going to be analyzing that number of factors that it has. So we're going to say this is called a number. And we're going to start a colon. Just like in Python, with anything we've done so far, if you're creating a code block, we always use a colon to say that, hey, like everything that belongs to this function called factor count is going to be inside the code block, right? And then here we're just going to calculate the number of factors this number has. So what we want to do is we'll document that and talk about how determines the number of factors the argument has, right? And this word argument is just referring to this, and we also have to describe that. So we're going to go args, and we're going to tab 1, so I'm going to say number, an integer number that we are trying to find. Let's make it less wordy. An integer number, or we can just say an integer needed to determine the number of its factors. Okay. And we have to now provide something back, a result of a function. And to grab something that's been calculated or been processed by a function, we call that return. We're returning something. We're returning a data back to our original flow of our program. So we're going to write returns an integer, which is the total amount of factors the argument has. Right. So most often when you do, this is called a doc string, where we are documenting a function, you would require all this, a single line of explanation of what the function does. You list out all the arguments and what data type it is and what it's supposed to do for a function, and you talk about what's been returned by your function. So let's actually run this code. We're gonna just do our good old factor finding for loop. We're gonna say for divider is in range from 1 to number plus 1. Okay. But that's going to represent all the possible dividers we can have for 1 to number plus 1. And we're going to say, well, if number modulus divider is equal to 0, that means it's divisible. So that's a factor. So what we're going to do is say counter plus equal 1. That means I need to have a counter variable set to 0. All right. And at the end of the for loop, we're going to say, well, return counter, because that's the total sum of all the factors it has. So, and then we can say this is the end of factor count just for documentation purposes. And now we have this code. We have this factor count code, which takes a single number and determines its total number of factors it would have. And what happens is we're just defining this so that we're saying in our Python file, this is defined and it exists and is callable. We can now use this function, much like how we use int, input, range, and print in our code, so that I can call upon this anytime I need it now, because it has been defined somewhere in our code. So when our program runs, it's when we get to this portion of our code, it's going to say factor size is equal to whatever has been returned by this function called factor count, defined by the num. Okay, if we didn't have the statement there, we won't be able to assign a value from our result of our function. So it's very important that you actually have return statements for almost 99% of the functions that you will write. Okay, so with that said, all right, let's test this out. We can say 25, and it will say 1 has 1 factor, 2 has 2, and it will go like that. If you know from our previous programming journey, like any number with 2 factors is prime numbers, right? 11, 13, 17, and so forth. So for 1 to 25, we were able to determine numerous numbers that have multiple factors, like 24 having 8, so that has the most number of factors so far. So this really, its function is very useful. We can definitely just copy this code and use it in our future code whenever we need to like count a factor for some things. Another thing we can do is, if you think this is ugly, we can even create a newer function. We can say def is divisible, right? And we can take num1 and num2. Okay. And we can write a little doc string as well. Checks if num1 is divisible by num2. Okay. And we can say args num1 an integer, num2 acting as a we'll say this is our numerator, and another integer, this is our denominator. Okay, and then we're going to return. All right, returns true if num1 is divisible by num2, otherwise false. Okay, and then we can just write a very simple calculation straight into the return statement, because this code is very simple. We can just write that return num1 modulus num2 is equivalent to 0. It will actually calculate this, right? And if you choose to do so, you can even put it inside a quotation bracket. You don't have to. What it's going to do is, well, whenever we run this function, it's going to take a number here and a number here, and it's going to divide that, and it check if the result of our modulus operation was 0. Because if it is 0, it is divisible. Num1 is divisible by num2. Therefore, it's going to return true. So instead of us writing this, we can write a more cleaner code to say that if it's divisible for our number that's being provided by our argument and divider, right, we can do a counter plus equal 1. So we don't have to write a calculation here, but rather just use name of the function, and this will still work the same, and we get all our outputs like that. So main benefits of a function is for readability and for reusability, where we can take these functions now anywhere we want in our future Python code, and we can use them. Right? And it is much easier for you to debug or fix a function that does little single things rather than a really long a code that is not inside a function, where you have a very long, convoluted mess of a code that magically somehow solve your problem once, but if you have to make tweaks, you would have to make changes to so many variables. So it takes a lot of time. Whereas functions are single serving, they are tiny, they're easy to fix, and they make your code readable. Okay, so there are a lot of good uses and benefits to using a function. Anyways, thank you for watching. Stay classy.